Welcome back to Star Talk Radio. I'm your host, astrophysicist Neil deGrasse Tyson. I also serve as director of New York City's Hayden Planetarium at the American Museum of Natural History. My comedian co-host this week is Chuck Nice.
Hey.
Chuck, welcome back.
Thank you, Neil. It's good to be back, man.
Chuck, I have to say, I was channel surfing the other day.
Yes?
I was on some obscure cable channel,
Okay.
and it was like the top 30 videos of drunken people at parties, and there you were commenting.
Yes.
You know, we can give you better gigs than that, I think.
Well, you know, that's my wheelhouse, man. That's where I'm a Viking. I am an expert on drunkenness,
commenting
on drunken buffoons, idiots. That's
it was a fun show. It was great to see you there.
That's where I excel, and you know, that's why I know my career is going well. Like the more obscure the cable network, the better off I'm doing.
Well, as you may know, in a previous show, we spoke with Professor James Kaku of the University of Minnesota. And you might ask why.
Yeah.
He's a professor of physics, and he authored the book, The Physics of Superheroes. And, you know, it turns out that superheroes, if you think about them through the lens of a physicist, you can learn a lot of science by looking at what laws they obey and what laws they violate.
I'm sure they violate a lot more than they obey.
That's for sure. You know, there's like how strong they are, how fast they move, how well they deflect bullets.
Yeah.
And so all of this is about physics. And so
Laser vision.
And so I wanted to like bring in some help on this one. And so who other to bring in for this than my friend and colleague, Professor Michio Kaku. Michio, welcome to Star Talk Radio.
Glad to be on, Neil.
This is actually not your first time on the show. We had you once to comment on the earthquake and tsunami in Japan. So thanks for doing that for us.
Glad to be on.
That many months ago. So I've got you on here not just because you're any old ordinary physicist, but of course you've written about the relationship of physics to culture and life. In fact, your recent book, The Physics of the Future, How Science Will Shape Human Destiny and Our Daily Lives by the Year 2100. You know, I just realized that date is far enough in the future that no one alive today will be alive then. So you could say whatever you wanted in that book.
I don't know about that. Some people think that some people alive today will see the year 2100.
Oh, is that a chapter in the book? Right? How to test if this book is correct.
Simply don't die.
Yeah, don't die for 100 years.
Don't die. So I just thought if that book said, you know, in the year 2030, maybe we could hold you to that. But all right, we'll give you a pass on that. So in this section of my conversation with James Kaku, who I'd met up with in Los Angeles, we were both at an educators conference, coincidentally, and he wrote a book on the amazing story of quantum mechanics, and that got him thinking about whether any superheroes tapped the quantum universe. And so, Michio, every physicist knows quantum, but you live the stuff, right? And so what is the freakiest thing about quantum you would tell, top 3 freakiest things you would share with the public?
Well, first of all, that's my day job. I do quantum physics for a living. That's what I get paid to do by the city of New York. But if you think about the superpowers of the X-Men, almost all of them...
Wait, just a second. It's not that the city has quantum physicists, you know, arming the borders.
I was about to say, I didn't even realize that we needed a quantum physicist on staff here in New York City.
Professor of physics at the City University of New York, on City College campus. Okay, there we go.
I just thought it was the Bloomberg administration. Right. Hey, well, you know what we need? We need a physicist.
Some quantum folk. I interrupted, Michio. Go on.
Well, if you could control the laws of the quantum, then you could, in fact, have most of the superpowers of the X-Men, most of the superpowers of science fiction. Teleportation, for example, is something we already do at the atomic level. Beam me up, Scotty, right?
He says we like this at everybody's house. We have a teleporter,
right?
I can't
wait. And invisibility. We physicists are using the quantum theory to create objects that are invisible. The Pentagon, of course, is not stupid. They're giving us millions of dollars to perfect this art. And the Human Torch might be possible if you have nanotechnology. Graphene could give you the power of Superman, that is indestructible materials.
Graphene is that new flat carbon...
It is the strongest substance known to physics. You could take an elephant...
Not known to man, but known to physics.
Forget about men, right? Put an elephant on a pencil and put the pencil on graphene, and graphene will not rip. It is the strongest material known to science. It's what Superman's cape is made of.
Or should be if they didn't think so at the time.
But will the pencil shatter is the question, if the elephant is standing on it.
Also, X-ray vision. We already have what is called backscattered X-rays that can give you the X-ray vision of Superman, almost identical to the power seen in the comic books.
Well, let's see what James Cacalio says about his favorite quantum superhero.
Quantum mechanics is the branch of physics that deals with the properties of atoms and how they interact with light.
So the science of the small.
Very small, that's right. There are some superheroes that basically have quantum mechanical properties.
Like who? Give me an example.
Well, Dr. Manhattan in the comic book and movie Watchmen.
Oh, yeah, I didn't read the graphic novel, but I saw the movie. I think that's like best of genre. What a stunning film that was.
Well, I must say then, I thank you very much because I was the science consultant on that film. Now, of course, they followed very closely to the graphic novel, so, if I told them that some science was wrong, but it was in the comic book, they were going to go with the comic book.
They go with the book and not you.
That's right.
Because you're just physics professor from Minnesota.
Exactly.
Okay.
But there's a character who's taken apart at the subatomic level, through sheer force of will, is able to reassemble himself, and now he has independent control over this wave-particle duality. By teleporting himself, he can extend his wave all the way to Mars.
Is that how that works?
And then he basically quantum mechanically tunnel. He can make his wave show up at some distant location, and then he would appear there.
So what you're saying is, in quantum mechanics, since a particle can also be a wave, the wave can move across space and then become a particle again in another spot without the particle ever physically moving from one location to another.
I couldn't have said it better.
Okay, and so in Watchmen, he has become a macroscopic
quantum object. That's
so
exactly
where he
right.
can say, I can become this particle wave duality myself.
Yes.
And I can at will become the wave and show up where the wave traveled in another spot and reassemble myself, and there I am.
Exactly. In quantum
Why can't we do that?
Because we don't have independent control over our quantum mechanical waves. Our quantum mechanical waves, we have them. They're a trillion times smaller than a nucleus. And so they're undetectable, they're unobservable.
We're too big.
We're too big,
and we have a small wave because it's the opposite of their size.
Exactly right.
Okay. And small particles have big waves.
Here's another thing that Dr. Manhattan can do. Schrödinger will say that the quantum mechanical wave function contains all information, past, present, and future, about the evolution of the system. Dr. Manhattan has knowledge of both the past, present, and his future.
Oh, so that's why he would sort of drift off and
be able
reflect
to,
on...
and know what was going to happen.
Wow.
Because he had independent control over his quantum mechanical wave.
So they thought this through a bit.
You know what? I've talked to the artists and no, they didn't.
They didn't.
They
stumbled on it.
But, just because some choices were made for random reasons doesn't mean that I can't obsess over the physics that would underlie them if it was done deliberately.
Michio, let's back up for a minute. Let me ask you something. I don't think most people think about or reflect on the difference between classical physics, which is really our everyday experience, and quantum physics. So could you give me like a 1-minute version of how we should think about the difference between the two?
Well, if I had a super microscope and could look at an electron, I would see it disappear, reappear someplace else. I could see it being two places at the same time.
This is really useful stuff to have a power to do, isn't it?
Yeah.
That's right. In fact, that's why we have lasers. That's why we have transistors. Lasers and transistors violate every single aspect of common sense. They totally are non-commonsensical.
So our common sense issues forth from the classical physics realm.
That's right. Common sense is wrong. Sorry about that. Okay. What you believe in is common sense. Everybody knows that's common sense, but it is wrong. At the atomic level, electrons can beam across. We do this now regularly with our devices. We can beam electrons 600 meters. That's the world's record now for quantum teleportation. Mm-hmm. And they can be two places at the same time, and they can enter parallel universes. So these are parallel states which Einstein thought was so freaky, so bizarre, so spooky that he couldn't get his head around it. Even Einstein had a hard time. But hey, that's why we have lasers. That's why we have iPods and GPS.
There's no hope for the rest of us if Einstein could not wrap his head around that.
But if you could master that at the macroscopic level, that it's you and me at our level, you would have the power of a god. You would be able to manipulate matter at will.
No, then everyone would be a god, and we'd have to invent a new kind of power that none of us had.
Who do you pray to then if everyone's a god? Right?
The mediocre guy. The guy with no powers at all.
It's like, whoa, I want that.
That guy's our god now.
James Kakalios chatted a bit with me about just the role of quantum physics in modern technology, and let's see where he takes us on that.
Here we are in the 21st century. We were promised jetpacks and flying cars, and we got cell phones and laptop computers instead. The difference is the writers of the science fiction pulps and comic books thought that we'd have a revolution in energy necessary for jetpacks and death rays.
And flying cars.
And what we got instead was a revolution in information. That information age is made possible by semiconductors and solid-state physics.
All of which is founded on quantum mechanics.
All of which is made possible by quantum mechanics, exactly right. The first science fiction pulp magazine, Amazing Stories, starts publishing in the beginning of 1926. Also publishing in 1926, Erwin Schrödinger, publishing the Schrödinger equation that would be the foundation of modern quantum theory.
So this is where he says not only is matter, it's also a wave.
Correct. And he found basically
the wave-particle duality.
He guessed the equation that would describe these waves. You tell me the forces acting on the electrons in the atom, and I'll tell you what this wave-particle duality function is doing. And so from this basic physics, a generation later, we get the transistor and the laser. A generation later still, we get iPods, cell phones, laptops, DVDs, everything without which life is not worth living. None of these are possible without the transistor or the laser, neither of which is possible without quantum mechanics. If you went to Schrödinger and said, "Nice equation, Erwin, what's it good for?" He's not going to say, well, if you want to store music in a compact digital format.
Right.
But
if you want to make an iPhone one day,
right,
yeah.
But without this basic curiosity-driven research, the world we live in would be profoundly different.
Wow.
Tells it like it is.
That is awesome. I just like the fact that he mocked him with his own name.
Erwin. So, Michio, most people, we get back to our common sense of the world. Most people, you let go of an object, it drops. You walk, there's a force, rain falls from the sky. And that's how we built our common sense of the world.
Right.
Newton's laws and Galileo and all these folks operated in this classical world. But 100 years ago or so, people realized that the fundamental identity of the world is not prescripted this way. And what enabled that? Was it microscopes or accelerators? Didn't you make a particle accelerator in your house one day?
That's right. When I was in high school, I built an atom smasher, 6 kilowatt, 2.3 million electron volt atom smasher in the garage.
Okay.
I blew out every single circuit breaker in the house. My poor mom thought, oh my God, he's blowing out the circuit breakers again. And she thought, why can't I give him a baseball or a basketball? And why can't he date a nice Japanese girl? I mean, what's wrong with him? He builds atom smashers in the garage. But I can't complain. It got me into Harvard.
Yeah.
So you were early on trying to develop a new kind of common sense that was not founded in classical physics.
That's right. Our common sense conception of the world is totally wrong. When I look at myself in the mirror, I don't really see myself as I really am. First of all, I see myself as a billionth of a second ago, because that's the time it takes for light to go from my face to the mirror and back. Second of all, I'm actually a wave. I'm actually vibrating, and some of my waves do go to Mars and Venus.
When we come back after the break, we're going to find out how much time Michio does spend on Mars and Venus, the waves that he sees. You're listening to Star Talk Radio. Follow us on the net on startalkradio.net. We'll be right back. If you recognize your theme music, you'll know this is our superhero show of Star Talk Radio. I'm your host, Neil deGrasse Tyson, and I've got with me Chuck Nice.
Yes, good citizen.
Comedian Chuck Nice, tweeting at Chuck Nice Comic.
That's right.
Check him out. And also with me, our special guest, Professor Michio Kaku. In the first segment, we talked about quantum mechanics and superheroes. Who would have thought there was such a connection? In my running interview with James Kakalios, professor of physics at the University of Minnesota, he wrote the book on superheroes called The Physics of Superheroes. He actually describes a connection between superheroes, their powers, the subatomic world, and astrophysics.
Sweet.
It's sweet, and that's my favorite subject. So let's check out where he takes us there.
One of my all-time favorites has to be the atom. a DC comic superhero who could shrink down to subatomic size, not just because his size changing was a cool power, but in his secret identity, he was Ray Palmer, physics professor.
So therefore you have a secret passion that...
He was a role model. And this you will appreciate because there's an astrophysics connection. Ray Palmer developed a device to shrink that used a lens created from a white dwarf star.
This would be the star at the end of its evolution. So the sun is going to become a white dwarf.
Right.
The remnant core of what we now enjoy as the full sun will one day lose all its outer layers and lay bare a dead core, and life on Earth will be long gone by then.
And in his origin story, he finds this white dwarf meteorite, and he's struggling, huffing and puffing as he brings it to his car.
Because white dwarf matter is very dense.
It's extremely dense. It weighs about 3 million grams per cubic centimeter, whereas water weighs 1 gram per cubic centimeter.
3 million times the density of water.
Correct. And we look at this rock, and if we assume it's a sphere with a radius of 6 inches, we can understand why Ray Palmer is huffing and puffing, because it should weigh over 50,000 tons. Okay. But I must point out that this is not actually a blooper, and that is because we physics professors are just that strong.
Well, you see, size doesn't matter then, right?
So, Michio, are you that strong?
No, but maybe Superman might be. People say Superman came from a planet going around a red star. Why not coming from a white star? If Superman were made out of white dwarf material, he would be invulnerable. He could take any bullet, he could take any kind of explosion, and he'd come out smelling like a rose. Of course, there's a problem. He'd also sink to the center of the Earth.
Just ignoring that complication, though.
Right.
But, Chuck, over the break, you mentioned something. You were reflecting on this wave-particle duality about what if you could do that as a full-up human being.
Yeah, because Michio said that atoms actually exist in places at one time, and it sparked in me remembering the movie Watchmen, where Dr. Manhattan was very engrossed in this experiment that he was working on and realized he had been neglecting his wife. And so he making love to his wife only for her to realize that he was also still working on his experiment in the next room.
So here's a science experiment. Take an electron and have it make it love to its wife and see whether it could also coexist someplace else.
Michio, is that what you do in your lab?
You see, being a physicist can be fun.
Electron porn, atomic porn.
Atomic porn. All right. Michio, you're my kind of man.
James Kakalios also talks about a power over the periodic table of elements. You remember that mysterious charter boxes that hung in your chemistry class?
Well, no, I went to a public school. We couldn't afford the chart.
Those are the kind of pinups he has at his high school. The pinning of the periodic chart.
Okay, in my high school, the Bronx High School of Science, there was a periodic table of elements in gym class. Right?
Oh, right on.
Let's see what he tells us about control over the properties of elements themselves.
There was another character published by Gold Key, Dr. Solar. You notice that when these physicists are disassembled and manage to reassemble themselves in quantum powers, they still insist on being called doctor. I suppose
that is an interesting fact.
I suppose if you could survive graduate school, you're going to insist on this. He came first, long before Dr. Manhattan. Anything he touched suddenly changed into another element.
So he was a tactile alchemist.
Well, not just tactile. He was a tactile reverse beta decayist. He was basically only transforming things one up the periodic table.
Oh.
And there is a...
So he would touch an element and it would become a heavier element than it was before he touched it.
But just one space heavier, only one proton more.
Okay.
And so he was inducing a neutron in the nucleus of that element...
To decay into a
proton and an electron, thus becoming the next element over. This is a known, real physical phenomena, and the fact that they limited it only to that implies that they were, in fact, invoking this nuclear reaction.
It means somebody took Physics 101.
Well,
in fact, that's probably 102.
201.
201.
There's a small catch there. When you transmute one element to another, it becomes highly radioactive. There's a burst of neutrons that'll disintegrate your body, and you will die in the process. Sorry about that.
But ignoring that complication.
Yeah, why you got to be such a killjoy?
All right, so we have quantum powers. We got super dense powers. We have possibly powers locked within stars in the universe. How about supernova power? Michio, what do you think of that? Can we harness that one day?
Well, there is a superhero that does that, Phoenix. Phoenix is the most powerful of all superheroes ever conceived of by the human mind. Wow. Phoenix actually appeared in the last X-Men movie, X-Men 3, I think. And Phoenix could destroy an entire planet.
Yeah.
It was the strongest, most powerful superhero.
Well, just to clarify, so a supernova, a high-mass star at the end of its life, goes unstable after it runs out of fuel in its core. It collapses, and there's heat generated from that collapse that blows the guts of this star to where else but smithereens.
Right.
Right.
And guess what? That power, of course, in the X-Men resides in a woman.
Is that
a woman scorned?
That's
Watch
right.
out. To blow up planets.
And she is PO'd, buddy.
All right. So we do have supernova power. How about a black hole power? How about that?
I've never seen that in the movies.
Because that would be kind of a dual power. There's like if you go too close, you get lost. But in the vicinity of a black hole, it's quite radiant.
Right.
Because all this matter is trying to get in, and the hole is very small.
Right.
And so it starts to spiral in. It gets hot from spiraling, and it gets so hot it radiates X-rays.
Yeah. However, there is a theory that says that at the center of a spinning black hole, there may be a gateway to another universe. That's the solution of Einstein's equation, if you follow the math. And Alice in Wonderland exploited that.
You were there.
That math went right by me. I don't know how you follow that math.
Wait, so Michio, you think this is what happened in Alice in Wonderland?
That's right. Alice in Wonderland was written by a professional mathematician, Professor Charles Dodgson of Oxford University, writing under the pen name of Lewis Carroll. And the looking glass could be the center of a black hole. It is mathematically, there's a one-to-one correspondence between the center of a black hole and the looking glass of Alice.
A spinning black hole.
Spinning black hole, that's right.
Right. Or it could be that that doctor found his way into some really cool mushroom tea.
We won't talk about that.
Again, that's the Dr. Jekyll, Mr. Hyde version of that. So there's power over the periodic table. I think that's an untapped talent that no one's talked much about.
No, but and now, of course, as the stupid guy in the room, what would be the purpose of that?
You get gold from nothing.
Okay, there you have it. Thank you very much, sir. I am sufficiently educated. Makes perfect sense. I want that power.
So Michio, I know you're a brilliant lecturer, and though I've never actually attended one of your lectures, I've certainly seen you speak and lecture in person and on television. Do you ever invoke superhero powers in your Physics 101s?
Well, yes, in the sense that people ask me how did I get into theoretical physics and string theory and stuff like that. When I was a kid, I used to idolize Albert Einstein, but also used to watch Flash Gordon on television. And I'm not the only one mesmerized by these figures. Carl Sagan used to read the John Carter of Mars series.
What is that series?
John Carter of Mars series was created by Edgar Rice Burroughs, who created Tarzan. And John Carter goes to Mars and becomes a superhero on Mars because of low gravity. Now remember that this was back in the 20s and 30s. Later, some people said, hey, let's make a comic book around John Carter of Mars, except put him on Krypton instead.
So you tell me Superman is derivative product.
That's right. Superman is a ripoff. It's a ripoff of John Carter of Mars, who's coming back next year. Disney is coming out with a movie on John Carter of Mars next year.
Wait, did John Carter have a cape?
No. Well, in the comic book, he did. He was made into a comic book. I used to read the John Carter of Mars comic books when I was a kid. And yeah, he had a cape, and he has superpowers, and he battled the Tharks of Mars and saved the princess, Deja Thoris, and that became Lois Lane.
That's cousin of Deja Vu, Deja Thoris. Michio, Chuck, if you had a superpower, what would be your top superpower?
Oh, wow. Man, that's a good one. I don't know. I kind of love teleportation.
All right,
but I don't want it to be just teleportation here on Earth. I want to be able to teleport to anywhere in the universe without any ill effects.
No side effects.
Right.
No nausea, no constipation.
Right, exactly.
Radiation sickness.
No radiation sickness.
No constipation.
No constipation. Right, exactly.
Michio, how about you?
No dry mouth.
Well, the answer is obvious. If you're a Green Lantern, you control the power of a god. You can materialize materialize energy in any shape or form and absorb all the superpowers of everybody else.
Well, there you go. What's left?
Yeah. See, that's too much power for me to have. You're a responsible adult. I know I couldn't
want to be a
handle
god,
that.
huh?
Right? I know I couldn't handle that.
See, I'm a little more modest with. I want to be able to read minds. Then you could read the mind of the criminal before the crime is committed, and you just let out the air in their tires or something.
You're a precog.
Never get mugged.
You're
There
a
you go.
precog. That's pretty cool.
Right, you never get mugged because you read the minds. When we come back, much more on Star Talk Radio, the physics of superheroes. Don't go away. Star Talk Radio returned. I'm here, Neil deGrasse Tyson, with Chuck Nice, comedian Chuck Nice, and Professor Michio Kaku. Thanks again for being my special guest on Star Talk Radio.
Could not be happier.
Yeah, so we're joining my interview that I conducted with a physics professor at the University of Minnesota, James Kakalios, and he wrote the book, The Physics of Superheroes. And I couldn't help but ask him about all the different powers and all the different branches of physics represented among these superheroes. So let's see what this latest segment tells us about electromagnetism, the science of light.
Professor X of the X-Men can read minds. That's not so crazy either. Right now, when we're thinking, there are electrical currents in our brain. And these electrical currents create electromagnetic fields that radiate outside of the brain. And
Are you sure everyone who's thinking has electrical currents going on in their brain? I think we all know people for which that's probably not the case.
More or less. Let's just stipulate, as the lawyers would say. And so there are electromagnetic waves that are being emanated. Now, these waves are weak.
So, in other words, when you have electrical currents, which we know is going on across the synapses of the brain, there's electromagnetic fields that are associated with those currents.
With those changing electric currents.
Okay, and
That's
so
right.
that field would get out of your head.
It can.
This is what's the machine that reads your brain? The EEG.
EEG.
Electroencephalogram.
That's exactly what that is doing.
It doesn't have to dig open your skull.
It's picking up those electromagnetic waves that are emanating from your brain.
So if that can do it, then surely Mr. X can do it.
Professor X.
Professor X.
He didn't go to graduate school for you to be called a Mr.
Excuse me.
But the waves that we generate from these electromagnetic fields are about 1 billion times weaker than the radio waves that are in the room right now, which is how you're able to listen to the radio.
So 1/1000th as strong. You need some awesome decoders for this.
So you have, and some very sensitive receptors. You know, in the X-Men movie, he uses a device, Cerebro, in order to find a distant mutant. And the room is in a large spherical
sphere.
Sphere.
Like a planetarium dome.
Exactly.
But under your feet as well as above.
I think the purpose of that shielded spherical room is not to amplify his powers, but to shield the radio waves.
It's the famous Faraday cage.
Exactly.
Tell Star Talk to listeners about a Faraday cage.
Okay, so a Faraday cage is basically...
Named after?
Michael Faraday, who was one of the founding fathers of electromagnetism.
You know what I heard? That if you value all of the industries and technologies that derive from his inventions, it's more than $1 trillion.
I believe it easily.
Mm-hmm. And this is the mid-1800s when he was busy.
And he was actually asked, I think by King George, what is the purpose of this device that he made using his principles of electromagnetism? And he said, I know not, sir, but I am sure that you'll find a way to tax it.
One day. So
a Faraday cage is basically a shielded room so that if any of the electromagnetic waves strike the walls
From the outside,
they are sent down to ground and don't make it inside the center of the room. To demonstrate this, I had a radio on in the classroom, but the whole thing was inside a large metal cage that was grounded so that none of the radio waves that were present in the room made it to the antenna. Mm-hmm. And I pointed out to the students that right now we don't notice it, we don't realize that we're inside a sea of electromagnetic waves, of radio waves. We don't see this, but we don't realize that we're surrounded by, and I raised the cage off, freeing the antenna to record the signal. At that moment, Tony Bennett belted out the word, love. And so I said, you don't realize that we are surrounded by a sea of love.
You did this in your physics class.
I did it once, and I'll never be able to do it again.
Yeah.
So sometimes timing is everything.
So basically that room wasn't just a cool visual effect for the cinematographer. It has some foundations in the physics of electricity and electromagnetism.
Why not?
Okay.
All right, so what we have here is, there's obviously much more to light and electromagnetism than was in that clip. Michio, Superman had X-ray vision. This is electromagnetism. I'm trying to think of any other sort of electromagnetic powers that people had.
Well, the Invisible Girl has the power of invisibility, which we will harness in the coming decades. The Pentagon is giving us physicists hundreds of millions of dollars to perfect invisibility, a la Harry Potter and the Invisible Girl.
The cloak.
The invisibility cloak.
That's
the invisibility
right.
cloak.
That's coming. And also a mind reading. I had my mind read. BBC television put me in an MRI machine that shot radio into my brain, and they looked for echoes from my brain. I counted down 1, 2, 3, 4, 5, and bingo.
They'll be counting up.
5, 4, 3, 2, 1. And then you can actually see a part in my brain light up like a Christmas tree inside my thinking brain, showing that I was thinking a certain thought. In the future, we will have the power of telepathy. We'll be able to look into people's minds, see what they're thinking or not thinking about, and be able to reproduce this with a computer.
But I got to tell you, that future is now. Yeah, I don't know if you've ever met my wife.
She knows where.
But let me tell you, she knows my every move, buddy.
And then you're the invisible man.
Yeah.
Right?
So when she actually asks you, where have you been tonight, she already knows.
She already knows.
She just fact check it.
And guess what? She tells me that she already knows. I'm like, nothing. I was just hanging out. She's like, you don't think I know?
So what I wonder here is if, Michio, what you're describing comes true, then whole branches of superhero powers become uninteresting to be written into superhero characters. What kind of fun, what kind of world are you doing? What are you creating for us?
Well, we will attain many of these superpowers, but hey, it's still neat, heat vision, eyes, X-ray vision. But it's still neat to have those powers.
I want superheroes to have it and not ordinary people, and you're telling us that ordinary people... I saw you on TV the other day talking about a superhero outfit that we might have one day. That's right. Super powerful. With any one of us could lift a car. Where's that power coming from?
Nanotechnology will have the ability to manipulate individual atoms. With graphene, as I mentioned, we'll be able to create super suits. With nanomuscles, be able to lift like the Hulk, gigantic objects. And the Pentagon, again, is pioneering this with exoskeleton technology. They want to create the super soldier of the battlefield. You'll have the internet in your contact lens. You'll blink and you'll be online. You'll be able to recognize objects, people's faces.
But wait a minute. At that level, what do you need the person in the suit for? Just send out the suit.
Yeah, send the suit. And plus, you don't want to be able to give people the internet in their brains because people would just sit around with their eyes closed all day looking at porn.
Has the military thought that one through all the way?
I don't think they have. Why aren't our soldiers fighting?
There's another really important part of superhero culture, and that's the fact that every one of them that I've ever seen has a nemesis. Some kind of complementary
kryptonite of
power.
Some sort, right?
And let's see where James Kakalios takes us on that one.
It's important from a storytelling because if a character has no vulnerabilities or no weakness, then there's nothing to challenge them and there's nothing for them to overcome. But it's also important from the physics. Whatever type of force you're exerting, there always has to be some counterbalancing force. The Flash, who could run at super speed, one of his arch nemesis was Captain Cold, who could create frozen regions. And if you put ice underneath the Flash, you could be as fast as you want, but if there's no friction between your boot and the ground, you're not going anywhere.
He's spinning his wheels.
He's spinning his wheels.
He'd be like in the Flintstones, where before the car starts, the feet just go.
That's right, in a constant circle blur.
Blur.
Yes.
Yeah.
And so very often what you might find is that the villains have a power that's kind of like the anti or the counterbalancing force for the hero's strengths. And so it provides an illustration that there's always two sides to a coin.
So that reminds me of that famous line from Batman Dark Knight, where Heath Ledger as Joker says, "I complete you."
That's right. Joker, in fact, is a perfect villain for Batman. Batman is the world's greatest detective. He's all about control. He's all about rationality. And Joker is all about chaos and insanity and unreason. And that's why they're the yin and yang together when Batman ever retires, the Joker in the comic books kind of goes catatonic because without Batman to push against, forces come in pairs.
So if Isaac Newton only knew that his laws of motion were being tapped in deep philosophical, cultural ways.
I know, he'd probably start drinking heavily.
So the opposite force, I like that.
Yeah.
And for every action, there's an equal and opposite reaction is the full up.
Yeah, but more on a philosophical level.
It's
like...
It's like saying, can there be good without evil?
Without evil, right.
Can they be beautiful without ugly? Can they be ugly without butt ugly?
Can there be butt ugly without fugly?
That's a new one. Where'd you get that one?
Well, you have the point that if we're all superheroes, if we're all gods, right?
Yeah.
Then it gets a little boring after a while.
It just gets so completely boring.
Right. Yeah.
In fact, I must say that in the Watchmen, there's a fight between two of them, each with superhero strength, and that just got really boring.
Yeah.
Right? I mean, I needed some difference of strength going on there.
Well, that's why the good guys always seem to be less powerful than the bad guys, except for Superman. Superman is like almost all powerful.
You didn't see Superman 2. That's probably the best of all the Superman movies, where he goes up against 3 super villains simultaneously.
And they all had exactly his power.
Right.
But they just weren't as smart as he was. That's what it was.
Right.
Right. So when you have this power and you have your nemesis, then you can actually write stories around it and then and have superheroes behave in a yin-yang sort of way. That's beautiful, I think.
I like it.
You're listening to Star Talk Radio. You can actually like us on Facebook. Just find us at Star Talk Radio. I actually tweet the universe at Neil Tyson, but you can follow specifically tuned Star Talk tweets at what other than Star Talk Radio. You're listening to Star Talk Radio and our second part of our interview with Professor James Kakalios on the physics of superheroes. When we come back, there's much more, especially when we talk about superheroes in pop culture and what it means to how we behave. You will believe that man can fly. I think that was the tagline of that one.
Yes.
Indeed. I think that's the theme to Superman 2. Just that the end of the break that we chatted about three supervillains with the powers of Superman. Just to recap, we are talking about the physics of superheroes on Star Talk Radio. I'm your host, Neil deGrasse Tyson, astrophysicist. We've got professional comedian Chuck Nice.
Yes.
And, of course, how could we do this without Michio Kaku, professor of physics at the City University of New York. And up till now, we've talked about quantum physics and astrophysics and electromagnetism and the physical concept of forces. This is like Physics 101 going on this program, and we're not done with you yet. Because in this is an interview that I had with James Kakalios, professor of physics, University of Minnesota, about his book, The Physics of Superheroes. And in this next clip, he talks about how superhero stories kind of reflect people's anxieties about the progress of science of the day. Let's see where he takes us there.
Back in the 40s, the world was a much bigger place. There were lots of parts that were unexplored. So often characters would get powers from finding some hidden artifact in some lost city or some part of the world that had never been studied. In the 60s, it was radioactivity that gave powers.
Because that was the new fear about the radioactive fallout.
Exactly. And then now it's more genetic manipulation. And it's more molecular biology that leads to these powers.
So you tell me superheroes have tracked the progress of science.
They track the progress of science, and they're a way of almost binding the cultural anxiety, whether it's the distant other or atomic power or genetic manipulation. It's a way of us trying to control these fears, and by, I think, giving these people amazing powers and then humiliating them by making them wear their long underwear out in public.
The pantyhose.
Spandex is a very unforgiving fabric.
Spandex. You know, because if you look at some of the old Superman TV shows, it's kind of it's wrinkly a little bit.
He is a little wrinkly.
You know,
he's wearing cotton stockings.
Cotton stockings, right? There was not the quite spandex we have today. So I'm intrigued by this idea that superhero powers are derived from the frontier of science that people still are a little bit afraid of. I mean, some great examples here. I mean, Spider-Man. Where does he get his powers from? It's
a radioactive spider.
A radioactive spider. You know, and
or look at Godzilla. Godzilla comes directly out of radioactive fallout. So here's radioactive fallout having its revenge on society.
And not only that, of course, I mean, Japan was the only country against which an atomic bomb was ever used.
Right.
And all of these monster movies that were traceable to the Japanese film industry, it's not an accident, I presume, that there's a sensitivity to the role that radioactivity played in creating those super monsters.
Yes.
Right?
Yes.
I guess
I just don't understand why they never moved.
What do you mean?
Because he only attacked Japan. It's like, I'm out of here.
We'll go to another country.
Yeah, I'm out. I'm going to Sweden.
Now, let me also say that there's a good side to mutants because we are all mutants. We're mutant monkeys. If it wasn't for mutations, we'd all be swinging in the trees right now.
I know some people who still are. What I wonder is that when you speak about mutant properties, but still admit that you're human, right? Because Superman was not human, but Peter Parker was human.
Right.
And Green Lantern, all these people are human. So what's interesting to me is there's some of these superhero stories that decided to look at the social ramifications of being different.
Right.
This is the foundation of the storytelling in X-Men.
That's true. Yeah.
Well, that's the Marvel Revolution, right, that Stan Lee introduced. Before then, everyone was a, quote, goody-goody. And so they were kind of boring after a while. They were very predictable. You could predict exactly what the next Superman comic book was going to do. Then Marvel comes along and makes him, quote, human.
Well, that's because Superman is DC Comics. And
DC
so Marvel
Comics,
brings up a whole other dimension of this.
So Marvel was in your face, reflecting the times of the 60s and 70s. And that's why Marvel overtook DC Comics, because of that fact that, you know, these were vulnerable people that had identity crises. Peter Parker always wants to give up being Spider-Man.
Yes.
Superman would never do that. Give up his suit.
The DC guys are always just filled with virtue. Like, you know, never would anybody receive powers and go, oh, my God, this is amazing. You are now all my slaves. Every one of you kneel before Zod. Like, I would have been Zod. That's why I don't have any suit. You know, I got to be honest.
So in this, I mean, it's a way to tell stories that through other means might not have been. So, for example, you see you have, was it Magneto? Where he realized his powers emerging from a concentration camp, and in Nazi
Germany,
in Nazi Germany, and so what's fascinating there is you could have told the story just of them being different, but they have these other layers that go deeper into our culture of what it was to be Jewish in a time of Nazi Germany, what it is to be gay in a time of homophobia, what it is to be a different skin color, what it is.
Superheroes are a reflection of society. For example, the gods. Look at Hercules. Hercules was the first superhero, a Greek superhero.
I guess so. I never thought of him that way.
Yeah, you go all the way back, and the superheroes of old were basically the gods of mythology.
Right, yeah. You just made me realize that Magneto is the first Jewish superhero. I didn't even realize that.
Now, wait a minute. Simon and Siegel created Superman.
What's that?
Superman, in some sense, was the first Jewish superhero.
No, just because his creators were Jewish doesn't mean Superman himself
was Jewish, because he can't be Jewish. He's from Krypton.
He's from Krypton.
You know,
have Judaism in Krypton.
No. Whereas Magneto came out of a concentration camp.
He was explicitly
Jewish, which is awesome to have a Jewish superhero. Like, I am going to rip this bridge from its foundation, and then I'm going to have a bagel with a schmear, and I'm good to go. Like, that's awesome.
And doesn't he even still have the...
He's the first circumcised superhero.
I wasn't going to get that personal.
Yeah, well, I was going to say that, and I said, no, let me not. And then Michio ups and... I will not question how you acquired that evidence.
Oh, that's awesome.
So Michio, the CERN super collider,
Right?
uses the word super in it. Is there you think there's something that we'll discover that'll give us superpower here, the superpowers of the future?
Well, there's got to be some way to make physics professors sexy, Captain Physics Professor. Right?
Just the CERN is the super collider. It's the European Center for Nuclear Research, and in an acronym, you spell CERN in French. But out of there, it's the most powerful accelerator in the world. So,
Right, 17 miles in circumference, recreating a miniature Big Bang right before our eyes. It's not going to eat up the Earth. There's no black hole that's going to be coming out of it, right?
But if there were, you'd be in charge of it. I bet you'd turn it into a superhero.
In your garage.
In his garage. I don't trust Michio for a minute. We've got to wind down this wonderful episode of Star Talk Radio where we focus on superhero strength and the physics derived from it. I've got to go my tweet of the week. Let me see what I got here. How about... Okay. I always wondered if superheroes are actually bad for society, because they somehow give the rest of us cause to do nothing. You've been listening to Star Talk Radio.
Let Superman do it.
Let Superman do it. Chuck Nice, thanks for being here. Professor Kaku, always great to have you on. As always, keep looking up.
Postulating to formulating equation. Eat a chicken, get some other girl named Lizzie. Dropping science like Galileo dropped the orange.